Hi everyone. So in this video, we're going to be continuing to talk about completing the square. So in the last video, we saw that completing the square is a process that can take a quadratic function from being written in standard form to being written instead in vertex form. So in this video, we're going to be focusing on the same thing, but specifically we're going to be looking at completing the square for quadratic functions of the form f of x is equal to ax squared plus bx plus c, where that number a is not equal to 1. So in the last video, if you remember all the examples we did, it was just x squared plus 5x minus 3 or x squared minus 6x plus 2. It was never 5x squared or 3x squared or negative x squared. So that's what we'll be focusing on in this video. So one thing I just want to mention is that, and this is going to be really important to realize as we go through the examples. So in this case, the vertex form will be something that looks like this. It will be f of x is equal to a times x minus h squared plus k. So basically what I'm saying here is that if you think about, if you go back to the last video and look at all the examples we did, they all started with just x squared, right? There was no number in front of x squared. And so similarly, when you completed the square, there was no number being multiplied with the x minus h squared. But in this video, there will be. And an important thing to realize is that whatever that number a is when you're in standard form, it's going to be the exact same number a in vertex form. So we'll keep that in mind as we go through these examples. Okay, so I want to jump right into an example. So the first one we're going to do is we're going to complete the square to put the function f of x is equal to, let's do 2x squared minus 8x plus 1, and we're going to put that into vertex form. So one nice thing that I like to do for these types of quadratic functions is to just kind of remind myself of the goal. So the goal in this case is we want our function to look like this. We want to have it look like 2 times x minus h squared plus k. So, important thing being that it's going to be a 2 out in front of that squared part. Okay, so I'm going to write down our function. So, and I'm going to, as usual, I'm going to kind of like move this 1 over. I'm not going to put a blank here just yet, and we'll see why. I'm just kind of moving the 1 over just to like get it out of our minds a little bit, because just like in the last video, we really start by focusing more on this part and kind of dealing with that 1 at the end. However, there's one other step that we have to do before we go through that process of figuring out what we need to add. So remember, we want our function to look like this, right? We want it to look like 2 times something squared. And so what does that mean? Well, that means we want to factor out a 2. So we're going to rewrite our function as 2 times x squared minus 4x. I'm not going to factor the 2 out from this 1. You could if you wanted to, but that would make this process more complicated. So the easiest thing to do here is to factor the 2 out just from the first 2 terms, and then just leave the plus 1 out here. And that's fine, right? You're allowed to factor something out from only one portion. And one thing that I think is always good is at any step along the way, if you were to kind of multiply things back out, would you still get the original function? And you would here, right? If you multiplied this back in, you'd get 2x squared minus 8x, nothing is actually here, you would not be multiplying this 2 with this 1, right? Because it's outside. And so you'd get 2x squared minus 8x plus 1, which is exactly what we started with. But now we want to figure out what needs to go here to complete the square. So basically our goal, like in the last one, is to make this part here a perfect square trinomial. So we're not worrying about this 2, we're not worrying about this 1, we're just focusing on what's inside these parentheses, because that's the part that's going to turn into this part, right? That's the part that's going to become the perfect square. So what number is missing in order to make this a perfect square? Well, we would want to have plus 4. So again, I think this is one that you can kind of see just by looking at it, by thinking like, okay, well, this would factor as x minus 2 times x minus 2. So I'll get I'll get a plus 4. Again, the rule for coming up with it is that you can take this number, divide it in half, and square it. And that's where this number comes from. Okay, so I'm now going to do something that is actually wrong. And I want to show you why it's wrong. So I'm going to write that on this. Actually, maybe I'll go over here so that it's not like in the way. But I'm going to rewrite our function. So what did we do so far? We added 4. And I'll underline that so we can see that that's where that came from. So thinking about what we did in the last video, what did we do when we added that new magic number that would make something a perfect square? Well, we also would subtract it, right? And so I'm going to do that, and we'll see why that actually ends up being a little bit off. So what did I do? Again, look, I added 4, I subtracted 4. Seems good, right? Seems like it's what we did last time. So I want to see why that's actually wrong. So how can you check whether something is right or wrong in this process? Like I said, you can always check at any step of the process by multiplying it out and seeing whether it still agrees with your original function. So let's see what happens if we multiply this all out and see whether it agrees with our original function. So I'm going to distribute this 2 in. So I get 2x squared minus 8x plus 8 minus 4 plus 1. So already we should be able to tell that this is not going to agree with our original function. So why is that? Well, our original function had a plus 1 at the end, right? It was 2x squared minus 8x plus 1. And so that's where this plus 1 came from. And so remember, why did we subtract 4? Well, the idea of subtracting 4 here was that it should be canceling out with this 4 we added. But if you look closely at what happened here, what happened to this 4 we added? Was it actually a 4? Well, if we look here, we actually added 8, right? We didn't add 4. We added 2 times 4, which is 8. And so in order to compensate for that 8 that we added, in order to balance it out so that we're not changing our function, it doesn't make sense to subtract 4. It makes sense to subtract 8. Right? So this is, I think, the step that most students get kind of thrown off about. And again, it just really comes down to the fact that when we added this 4, right, we were focusing on the inside of these parentheses, focusing on making that a perfect square trinomial. And so we ignored the 2 on the outside while we were doing that. But then when we're trying to figure out what it is that we need to subtract in order to balance out what we added, we can't. We need to go back to the context of the original problem. So we did not just add 4 because we added that 4 inside these parentheses. So what we really added is 8. And so we need to subtract 8. And so where does this 8 come from again? It comes from 2 times 4. So I'll make a note of that. So we actually added 8. And so if we actually added 8, what do we need to do? We need to subtract 8. So I know this looks kind of confusing right now, but so far every step has been the same. This adding 4 was the same. The only difference was, again, that we started by factoring out 2, but then that we also had to just be careful about what we did to balance it out. The whole step, the whole process, the point is to not change your function. It's to kind of move things around, shuffle things around, write them a different way, but never actually change your function. So let me just make a note here so that in your notes it says basically, why can't we add 4 to balance, or sorry, subtract 4 out the plus 4? And so here's the answer, right? We saw that we didn't actually add 4, we actually added 8. Okay, so what do we do now? Well, now we just kind of start cleaning things up. So from here, it's actually just like before. So we still have this 2 on the outside, but now we can factor this perfect square trinomial, right? We can factor this as x minus 2 squared. So again, I'll just do this here to remind you that's where that came from, the perfect square trinomial above. And then we have a -8 and a +1, so that adds up together to -7. And so that's our final answer. And so let's check it, because I think checking it is always a good way to just really understand why it worked the way it did, and also to, check whether you did it correctly. So we have 2 times x minus 2 times x minus 2 minus 7. So this would be 2 times x squared minus 4x plus 4 minus 7. Now if we wanted to put this, combine things, we need to actually distribute the 2, right? So we get 2x squared minus 8x plus 8 minus 7. And then we see that this simplifies to 2x squared minus 8x plus 1. And if we go back to our original standard form, that's exactly what it was, 2x squared minus 8x plus 1. So now we can see that this is correct. So just to repeat it one more time, what was the differences here? We were factoring out whatever that coefficient was and really keeping in mind that this is our goal, right? That's how you can remember that you need to factor that number out. Then we complete the square normally inside the parentheses. And then the only difference is when we go to figure out how to compensate for what we added, we have to take into account that number that we factored out. Okay, so let's do another example. So in this case, we're going to complete the square to put g of x is equal to 3x squared plus 6x minus 5 into vertex form. Okay, so same process as last time. So I'm just going to write down again what our goal is here. Our goal is to write this function as 3 times, x minus or plus some number squared plus k. So we want to have it in vertex form, specifically with that first number being 3, because that's the same first number we have here. And hopefully, by the way, you can see why that is, right? If you look at this example, when you multiply it out, the only way that you're going to get a 2x squared here is if you had a 2 out in front here. So hopefully you can see why that has to be the same number. Okay, so we take our function again, 3x squared plus 6x. I'm going to just kind of slide that 5 over so that we're not distracted by it. So just like with the last example, we want to start by factoring out a 3. We want to get it so that the first part is just an x squared. So we want to do that, we need to factor out a 3. So we have 3 times x squared plus 2x. So here we're going to be, adding some number. And then we're going to have to do something outside here too, right? And so we'll leave some space there and then minus 5. And so this is the part that we're focusing in on right now. This is what we want to make a perfect square trinomial. Okay, so what would we need to add here to make this a perfect square trinomial? Well, what would factor as x squared, or like what perfect square would give us x squared plus 2x? Well, it would have to be x plus 1 squared, right? And so that would give us x squared plus 2x plus 1. Or, as usual, you can also do 2 over 2 squared, and that would give you that 1. That's another way of finding that. Okay, so now we have to figure out what number we actually added, right? It would not be correct here to say minus 1. I would encourage you to try it, multiply everything out, and really convince yourself that it's not right. I think this, again, is the thing that most students forget. And I think if you just really convince yourself that it doesn't make sense by multiplying it back out, you're going to be a lot less likely to make that mistake. So what did we actually add? Well, we added 3 times 1, right? If we were to multiply this back out, this would actually be a plus 3. And so what we need to put here is not minus 1, but minus 3. That's how we're going to get rid of that. That's how we're going to compensate for that extra 3 that we added in. Okay, so now we can go and factor the inside part. So this inside part, as we mentioned, is going to factor as x plus 1 squared. And then, and here I'll just do this to emphasize that's where that came from. And then we have a minus 3, a minus 5. So together, those are going to give us minus 8. So let's check this out. Let's check whether this is the correct vertex form. So we have g of x is equal to 3 times x plus 1 times x plus 1 minus 8. So this is going to give us 3 times x squared plus 2x plus 1 minus 8. That's going to give us 3x squared plus 6x plus 3. So now we can see where the fact that we actually added a 3 minus 8. And so this is going to give us 3x squared plus 6x minus 5. And so if we go back and compare to our original quadratic function, that agrees, and so we're good. That is the correct vertex form. Okay, one last example, and this one is going to be a little bit different, but in a lot of ways very similar at the same time. So in this case, we're going to complete the square to put the following function. So this one's going to be negative x squared minus 3x plus 1. We're going to put that in vertex form. Oops, vertex form. Okay, so what is different about this one? Well, in this case, we don't have a number like 2 or 3. We actually have a coefficient of -1, right? It's just a negative sign, but that's the same as having a -1 there. And so what does that tell us about how our final answer is going to look? Well, it's going to look like this. It's going to look like negative x minus h squared plus k, right? We're going to have a negative sign out front. So when we go and do this one, it's actually really the same idea. It's just that now instead of factoring out a number like 2 or 3, we're going to be factoring out -1. So again, just from the first two parts, we're going to factor out a negative sign, or you could write it as -1 if you wanted to. And so what are we left with? Well, we're left with x squared plus 3x, right, if we factor out that negative sign. Then we're going to leave some space here to figure out what we have to put here. Then we're going to put something else out here, right, and then we have plus 1. Okay, so what number has to go in this blank? Well, this is one of the ones where it's an odd number, so it's kind of hard to just figure out in your head what's going on. Really what you want to do is use that b over 2 squared rule. So if we take 3 over 2 and square it, that is going to give us 9 over 4. So we're going to be adding, let me give a little more space here. We're going to be adding 9 over 4. Okay, so just like before, there's a little bit more going on than what might initially seem. So it looks like we just added 9/4, right? But just like in the last examples, I want you to think about what would happen if we were to redistribute this negative sign and break everything down. So we would get negative x squared minus 3x, and then we would have minus 9/4. So we did not actually add 9/4, we actually subtracted it. So how do we compensate for subtracting 9/4? Well, we have to add it. And I know it looks funny, it looks like we're adding 9/4 twice, but when we do that checking step at the end where we go and multiply everything back together, you'll see that it works. And even at this stage, maybe I'll just even write this down because I think it's really important to really convince yourself this is true. So let's say we were to distribute this negative sign in. I'm just going to write this down. I'm going to erase it afterwards, but let's see what this would look like if we distributed the negative sign in. We would get negative x squared minus 3x minus 9/4. And then this stuff is still outside the negative sign, right? So this will still be plus 9/4. This will be plus 1. And so what will happen is these two will cancel each other out and we'll be left with x squared minus 3x plus 1. And that's exactly what we started with. Or negative x squared, sorry, minus 3x plus 1. So you can really see if you multiply it out that truly we subtracted 9/4, even though it looks like we added it. And so the correct thing to do to compensate is to add 9/4. Okay, so what is our next step? Well, this is now our perfect square trinomial, right? And so this is what we need to factor as a perfect square. So we leave this negative sign on the outside, and then how does this factor? Well, remember that the rule is basically that whatever number you squared to figure out your third number here, that's the number that's going to appear in the factored version, right? It's like half of that middle term squared gives you the third term, but half of the middle term on its own is what you have in the factored version. And we'll see, again, when we multiply this out, you'll hopefully be really convinced that this is the correct way to do it. And then out here we have plus 9/4. And then we also have plus 1, which we want to write as 4/4 in order to get this common denominator. So this is going to give us negative x plus 3/2 squared plus 13/4. So this would be our vertex form. So let's check that this gives us the same, if we multiply it out, that this is the same as what we started with. So if we take h of x is equal to negative x plus 3/2 times x plus 3/2, and then we have plus 13/4. So what's going to happen here, let's leave the negative sign on the outside and multiply these two things together. So we get x squared plus 3/2 x plus 3/2 x plus 9/4, right? If you multiply together 3/2 and 3/2, you get 9/4. Okay, so what do we do next? Well, we can combine these things. 3/2 plus another 3/2, well, that's just going to be 3, right? If you have 3/2 and then, or if you have half of 3 and then another half of 3, put them together, you get 3. So this is going to be x squared plus 3x plus 9/4 plus 13/4. Now we can distribute in that negative sign. So we get negative x squared minus 3x minus 9/4 plus 13/4. And if we combine our fractions, we get negative x squared minus 3x, and this is going to become plus 4/4. And finally, that is negative x squared minus 3x plus 1. And if we look back at our original function at the beginning of this, it was negative x squared minus 3x plus 1. All right, so that is it for this video. This process really is the same as it was in the other video. The main things you just have to remember is to factor out, but only factor out from the first two terms. Leave that number, the one that doesn't have an x attached to it, leave that by itself. Just leave it to the side. Factor out only from the first two terms. Then complete the square only in those parentheses. Leave the whatever you factored out on the outside. But then when you go to figure out what you have to add to compensate or subtract to compensate, you have to take into consideration what was factored out here. So let me, in this case, I'll underline this and this, right? That's where that plus 9/4 came from. And then always check your work. I think checking your work, again, is just the best way to really understand how this process works. All right, I'll see you all in our next video.